This is our last objective for 1.3, X and Y intercepts. An x-intercept is the point or points where our function hits the x-axis. Y is 0 there. A y-intercept is when our function hits the y-axis and x is 0 there. So an x-intercept is when y equals 0, and a y-intercept is when x equals 0. We use this idea algebraically, but we can find intercepts just visually if we have a graph, like in this next example. All right, so if we have a linear equation, right, a line, we are going to have only one x-intercept and one y-intercept. Here our x-intercept, where we cross the x-axis, is down at -4, and you can clearly see that this is the coordinate point -4, 0. So we can see that our x-intercept is -4, and because it's on the x-axis, y is actually 0 there. So our x-intercept, it's totally fine to write it either way. You can write it just that it is -4, or you can write that it's literally the coordinate point -4, 0. Either way is great. Then our y-intercept is where our line hits the y-axis, which we can see is at 2. And we can see that that is the coordinate point 0, 2. And x is 0 there because it's the y-intercept. So we can write that in two different ways. Similarly, we can say that the y-intercept is 2, or we can say that it's the coordinate point 0, 2. All right, that was linear, and so they each only had one, like there was only one x-intercept and one y-intercept. But if we have a nonlinear function like this parabola here, or any type of nonlinear, there's always a possibility that we'll have more than one intercept for x or y, that we won't have one. In this case, we can see that we do have two x-intercepts here at -3 and over at +1, and then we have one y-intercept down at -3. So our x-intercepts are where y is 0, -3, and 1. Now I'm not going to put parentheses around that because it's not a coordinate point. I'm simply listing two x-intercepts, so just be careful. And then we only have one y-intercept, and that's down at -3. All right, another way that we can find intercepts is just algebraically, so this is obviously not visual. So we're going to use the idea of setting the opposite variable to 0. So when we're looking for the x-intercept, we are going to let y be 0, since that's what's happening there. So I'm going to rewrite this problem, and I'm going to plug in 0 for y. Now you can clearly see that that's just going to turn this term to 0, but I'll just write it anyway. So we're just left with 5x equals 30, and therefore our x-intercept is 6. Then to find our y-intercept, we're going to do a very similar thing and let x be 0. And so it just turns this first term into 0. So I'm not even going to write the 5 times 0. It goes away because we're letting x be 0 here. So we're left with 2y equals 30, and therefore our y-intercept is 15. Now this is clearly a linear function because x and y, their exponents are both just 1, right? If it was x squared or y squared, it would be quadratic, and therefore we might have more than one intercept somewhere. But in this case, this is just a line in standard form, and so we only have one intercept each. The last example is also algebraic, but it's a parabola, since x is being squared. So this is a quadratic function, it'll form a parabola. So in order to find the x-intercepts, which I know we're going to have more than one, potentially 2 because x is to the second power, and that tells us how many potential solutions we have. So we're going to let y be 0. And then to solve this, I'm going to add 4 to both sides. And then we're going to solve this quadratic by taking the square root of both sides, so we're using the square root property. Remember your plus or minus because squared means we have two solutions. So positive and negative 2, that's where we hit the x-axis here. To find the y-intercept, and in this case there's only one because y is raised to the first power, we're going to let x be 0. So y is literally just negative 4. So this is not too bad. We can do this visually if we literally have a graph and can see it, or we can just do it algebraically. You just want to set the opposite variable to 0.